Alright, our goal is to find the area of the inscribed square. To do this, we really have two options. One option is we can find the diagonal of the square and lean on the formula from a rhombus and a kite, which is that area is 1/2 diagonal 1 times diagonal 2. The other option, which we'll show both, is we can find the length of a side and use the fact that the area of a square is the side length squared. Alright, so first thing we have here is we have the circumference is 24 pi. As we remember, circumference is given by 2 pi r. So if I drop in my 24 pi for circumference, that equals 2 pi r. I'll divide both sides by 2 pi, and that's going to give me a 12 for the radius. If I drop that into my diagram there for 12, we know that all radii in a circle are 12, so we can go ahead and extend to this side, and we can also extend this way. So hopefully that kind of sparks some interest in this first formula here. And if we apply that, we have diagonal 1 is 24, and diagonal 2 is 24. So we have area equals 1/2 24 times 24. So we'll grab the calculator really quick and go ahead and do a 0.5 times 24 times 24, and that's going to give us 288. So we have 288 for the area. We look back for the units real quick. There are no units listed, so we'll go ahead and say 288 units squared. Now, the other option was to find the side length. In a square, we know that the diagonals are perpendicular. So, since we have an isosceles right triangle, we know it's a 45, 45, 90 triangle. That means that the length of this side will be 12 root 2. And that would be true all the way around the square. So if I bring that back into my area formula, I have area equals 12 root 2 squared, which is going to be 12 squared times root 2 squared, which is 144 times 2, or 288. Both options work. It's really up to you, whichever's easier for you to think about. Honestly, I can take this either way. You could also break this into a few triangles if you'd like to. You have several options. I hope this helped.